Okay, guys, I'm going to jump straight into it. We're going to be dividing rational expressions. And basically, I say it's going to be two factors that you have to divide, in which the first factor is called the dividend. The second one is the divisor, even though they're in fraction form, which makes them complex fractions. Whenever you have fraction divide by fraction, rationals divide by rationals is complex. So basically, it's just my first factor times the reciprocal of our second factor, which is something we just learned in the previous video. So it's basically repetitive with just one step that we have to perform. And here it is. So I'm going to take my first factor and times it by the reciprocal of my second factor, which is the inverse of that fraction. Right? And of course, you know how I like to do. I like to pull out my common factors. This is my, I'll just do it in alpha order. A over a squared. And this is my b cubed over b cubed. Beautiful. So I can see that I can either prime factor my constants, which I always love to do. And if I subtract my powers, right? If I subtract my powers, I know that my bigger factor will remain at the bottom, right? My base with the bigger exponent will remain at the bottom. But if you don't like that explanation, it's just a to the 1 minus 2. And this is b to the 3 minus 3. Let's apply our rules of powers that we know. So we see that the common factors of 2's cancel, so I'm just left with 2/3. And a to the 1 minus 2 is a to the minus 1. And this is actually b to the 0. And based on our rules of exponents, right, we cannot have negative power. So that's the reciprocal raised to the positive power. And anything to the 0 power is 1, right? So, or yeah, so I'll show you another way. So this is 2 times 1 is 1, and this is 2 over 3a. Now, another way you could look at this is that I can say again that the a cancel at the bottom. So we know that the constant has a remaining factor of 2/3. So wherever the bigger power is where my variable remain. And look, this is b cubed divided by b cubed. These are common factors. Any factor divided by itself has a remaining factor of 1. So it cancels out. So we don't need to write back 1. It's redundant. And it's done there. All right. Here we have this nice big juicy expression here. So let's take a look at what that looks like in person. So this was x plus 2 over 7x squared plus x divided by x squared minus 4 over 7x cubed plus 8x squared plus x. So guys, again, it's my dividend fraction or dividend rational expression, which is my first, times the reciprocal, right, which is the inverse of the fraction, the divisor fraction. And just not to sound like a broken record, but you know, no cancellation of terms cannot occur. Cancellation only occurs when they're in factored form. So this is x plus 2. The GCF here is 1. So just x plus 2. And if we look at our two terms at the bottom here, they have a GCF of x. So I'm left with 7x plus 1. Be very careful here. You don't ever jump the gun and try to do the AC method. Always look to see if you can find a GCF before you can get into the grand business of factoring. And here I can say I have a GCF of x. So I'm left with 7x squared plus 8x plus 1. Isn't this beautiful? Right? So here we go. And this is x squared minus 4. All right, so now I can further factor, or if I want, I can just jump the gun and get rid of my x right away. Keep things nice and simple, but I'm going to leave them in factor form before we have our grand factoring finale. So this is x plus 2, right, over x times x, 7x plus 1, right, times x. Now I'm going to find factors of, I'm going to factor out this expression. My leading coefficient is not 1, so I'm going to do the AC method. Right now, there are some factoring geniuses that can look at this right away and see what the two terms are, right? I am not one of them. Sorry to disappoint you. All right. There you go. I suspected it would be that. And this is a difference of 2 squares. So that's x plus 2, x minus 2. Good. Now I can write everything in factored form and give my grand finale of factoring. So here we go. It's x plus 2 over x times 7x plus 1 times x times 7x plus 1 times x plus 1 over x plus 2 minus x minus 2 times x minus 2. Let's go for it. So it's, I like to say this, bang, bam, 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 bam. Oh, isn't that beautiful? So my remaining factor in my numerator is x plus 1. And my remaining factor in my denominator is x minus 2. Alrighty, so this is basically it for dividing rational. It's the same as multiplying, but this time it's our one of our factors, which is the dividend factor, times the reciprocal, which is the inverse of the divisor, which is the second factor. If you have any questions or concerns, my students, you know how to reach me.